Hope everyone had a fabulous holiday. Had all my kids came over. We ate too much turkey and played a lot of board games. Really didn't eat much for Thanksgiving. I didn't either. Usually, Rory, I'll have at least 2 plates of lunch and pile in some dinner. But I had 1 plate of lunch and didn't eat any dinner. Just I don't know. After my last leukemia run and then this COVID, I just don't eat much anymore. So it was kind of sad. I usually pig out, but that's all right. But yeah, we played a lot of board games. Yep. And did a little Black Friday shopping. My daughters and wife did a lot of Black Friday shopping. I just a little bit. Played more games on Friday. So fabulous, fabulous. All right, we got a dozen of us in here. Let's go ahead and go through our stuff this week. This week we actually have a pretty small. I should pull it up and show the assignment. The assignment this week is pretty small comparatively what we had. So if you're behind, here's a good opportunity for you to do some catching up here. See, there's my picture with Weird Al back in September. All right, let's get this up here. I'll show you this week's assignment. It's just 3 problems. Oh, there it is right there. All right. So if you're behind, this is a good week to get caught up if you didn't get caught up over Thanksgiving. Unit 2, Lesson 4 assignment right there. And what we have is 3 quadratic problems to solve, and we're going to use them by the square root method, which we're going to learn today. So it's just these 3 problems. Then, of course, it's show your work, so you got a big work area to show how you solve them, but you have to use the square root method. No other methods get credit. Don't try to factor it. Don't try to use the quadratic equation. None of that. The quadratic formula. This is just by square roots. So we get a credit because that's what this week's assignment is about. So let's pull up our notes and go through and see what we can learn today about the square root method. Actually, it's not too bad. Not too bad. Okay. Let's talk about radicals. Let's review radicals first. A radical is any expression with a square root or a cube root or whatever root it is. And the radical symbol looks like this, right? When you see that, it's a square root. Or if it has a 3 up there, it's a cube root. Or a 4, whatever number you're taking the root of. And it wants us to list the first 20 perfect squares. All right, I'm going to do that on a separate sheet of paper up here. So let's talk about what a perfect square is. A perfect square is something you can take the square root of that number, and it actually is also an integer. Okay. Case 2 is non-perfect squares. With non-perfect squares, we've got to break the radical down using the largest perfect square. So we need to know the perfect squares so we can use them to break down this. Take the square root of the perfect square and leave the leftover underneath the radical. In both cases, if there's a coefficient outside the radical, you got to multiply that by any number you take out. So let's list the first 20 perfect squares. So the first one is 1, of course, right? 1 times 1. So the square root of 1 is 1. The square root of 4 is 2, right? So 1 squared, 2 squared. The square root of 3. So perfect. This is a perfect square. Square root of 4. Square root of 5. All right, so this is really just 1, 2, 3, 4, 5, because that's what these are equal to. That's equal to 4. But it's a perfect square. So 6 times 6 is 36. 7 times 7. When working these problems too, it's not a bad thing to have this list in front of you, because you can use that, as you'll see when we get down here, to do these problems. And it saves you time thinking about it if you already got them written down. Okay, that's 7 times 7. So 8 times 8, 64. 9 times 9, 81. Square root of 100. So this is just 1 through 10 written as a radical. Written as a radical. Let's do 11. 121. 12 is 144. 13 is 169. 14, I believe, is 194. I better throw the calculator up just to make sure I don't mess that up. 14 times 14. Oh, 196. That's right. Has to end in a 6 if it's a 4 times a 4. 196. And then 15, 225. 16. See, that's going to end in a 6 also. 196? No, 256. I'm sorry. 196 was our last result. 17. 17 squared, 289. 18. 18 squared is 324. 19 squared, I really don't know. I don't know if I've ever had to calculate that before. 361 and 400, 20 times 20. That is the first 20 perfect squares, right? And we will use that when we simplify and write some of these. So write each expression below in the simplest radical form. It's not saying we have to solve anything. We have to write in the simplest radical form. So the square root of 49, well, that's actually a perfect square. Oops, perfect square. Square root of 49, that is the simplest radical form. There's no square root left. 225, that's a perfect square. 2 times 1 square root of 144. Well, the square root of 144 is 12. So this simplifies to just 24 because you got to take 2 times whatever comes out of there. Okay, how about this one? We're dealing with a fraction of the radical. You can actually rewrite that to be the square root of 4 over the square root of 9. Anytime you have a fraction, you can rewrite it. And the square root of 4 is 2, and the square root of 9 is 3. So that just equals 2/3. So these are good. If you want to print out these notes and go back and work these or fill in the ones I do as a study sheet, as a cheat sheet to use on tests, because remember, any notes you have, you can use on tests. Wonderful thing. How about this one? That's a square root of 1 over the square root of 81. So that's 1/9. So let's get the one that doesn't work quite so well. Let's do the square root of 112. All right, so look at the square root of 112. That's not a perfect square, right? 121 and 100. So we need to break that down. So let's see. If we're not sure how to break it down, it's even. We can always divide it 2. So it's the same thing as square root of 2 times the square root of 56. Same thing, right? Because you multiply those together, it'd be the square root of 112. 56 is not a perfect square, nor there's 2. So let's take another 2 out of it. Square root of 2 times the square root of 2 times the square root of 28. My radical's getting a little sloppy there, ain't it? Well, the square root of 2 times the square root of 2 is just 2. Square root of 28, that is not a perfect square. But we can pull another square root of 2 out of it. Square root of 2. Actually, we can pull square root of 4 out of that. We see 4 times 7, right? 2 times the square root of 4 times the square root of 7. So square root of 4 is another 2. So in its simplest form, this is 4 times the square root of 7. Which means we could have pulled a 16 out of there to start with. 16 times 7 is 112. But we just did it by breaking it out, dividing by 2s. When you have 2 of them, that are the same, then you can pull it out from under the radical. Square root of 2 times square root of 2 is 2. This is also the square root of 2 times the square root of 2, but I just wrote it as a 4. And then it comes out as a 2. So 2 times 2 is 4 times the square root of 7. Square root of 7 is it. That's as small as that gets. We can't break that anymore. How about square root of 250? That looks interesting. So that is the square root of 25 times the square root of 100. Right? 25. Oh, no, I'm sorry. Square root of 10, not 100. Square root of 25 times the square root of 10. Because 25 times 10 is 250. Well, square root of 25, that's one of our perfect squares. 1, 2, 3, 4, 5. Number 5 is the square root of 25. So this equals 5 times the square root of 10. And that's as simple as that gets. We can't break that down anymore. That's just 2 times 5. And so neither one 2 times 5, that's not perfect squares either. All right, I'm going to leave these other ones that you can practice with. Let's look over at these notes. Imaginary numbers. Let's review our imaginary numbers. Equations such as x squared plus 1 equals 0 have no real solution. So mathematicians have defined imaginary numbers to represent the solutions. All right, so we're talking about an imaginary number. The imaginary unit, I is a number in mathematics, and it equals the square root of -1. That's what I equals, the square root of -1. It's an imaginary number. You cannot take a square root of a negative number. So we use this when working with square roots of negative numbers. A pure imaginary form is written in the form a plus bi, where a is the real number and bi is the imaginary part. So when simplifying negative square roots, we're going to rewrite them. Negative a is going to be -1 times a. And then we'll break a down if it's not a perfect square. So we'll simplify it. So let's see, square root of -9. So we'll rewrite that as the square root of -1 times 9. The square root of 9 is 3, which just leaves the square root of -1, which is I. 3i is the answer. Square root of -9 is 3i, with I being the imaginary number that is defined as the square root of -1. That's the same thing as saying 3 times the square root of -1. These are the same. So when we have this, we just write it as I. All right, how about the square root of -196? So we'll check our list. 196, 11, 12, 13, 14. So this would be -1 times 196, which means this is I, and this is 14. So 14i is our answer. How about jump down right underneath that? -32. So that would be -1 times 32. 32, we can break that down. So square root of -1 times 2 times 16. All right, 2 times 16 is 32. Now 16 is one of our perfect squares. So that equals 4, the square root of 16. So, and this is I. So 4i square roots of 2. 4i square roots of 2. We break that down. All right, let's look at this bottom part, solving using the square roots method, because that's what our assignment says to do, is use the square roots method. Write all the answers in the simplest form. Okay, so to solve with the square roots method, we have to get x squared by itself. We can have a coefficient, but we'll get rid of the coefficient at some point. So in this, we've got to subtract 81. So we've got x squared equals -81. If we have x squared, and we need to have x because that's how you solve it, right? If you're solving means what does x equal? So we have to take the square root of both sides. Square root of x squared is just x. The square root of negative 81 is 9i, right? Negative 1 times 81. 81 is a perfect square. It's 9 times 9. Square root of negative 1 is I. So that is how we solve that using the square root method. We have to take the square root, get the x squared by itself, and take the square root of both sides like that. All right, let's try another one. Let's see. Let's jump down to number 10. No, let's do one that has a coefficient. Let's do one that has a coefficient. So let's do like 4x squared. So we got to subtract the 15 from both sides. So we got 4x squared equals negative 24. All right, negative 24. Divide both sides by 4. Get rid of the coefficient. We've got x squared equals negative 6. All right, so now we need to take the square root of both sides, and we'll put it in green there so it stands out. So x is what we get when we take the square root of x squared equals the square root of negative 6. That's as small as it can be because that's 2 times 3, right? 6 is. Oh, wait a minute. Negative 1's in there. It's negative 1 times 6. So it's actually I square roots of 6 because we can pull the I out. If we have that negative, we can pull that out as I right there. So x equals I square roots of 6. So this is the square root method where you set it equal to where the x squared is by itself, and then you take the square root of both sides. Let's see what else we have on our third page of notes. Oh, this is talking about the square root property that we're just talking. Quadratic equations in the form ax squared plus, let's see, plus c equals 0. There's no b in here, right? Ax plus b, ax squared plus bx plus c equals 0. But we don't have a b. We don't have a middle term. All we have is the first and the last term. If x squared equals n, then x equals the square root of n. All right? If x squared equals n, then x must be the square root of n. So what you do is you isolate the x squared, take the square root of both sides, and then simplify it. Oh, we forgot that over here. Both answers. When we take the square root of something, ooh, let me forget that. It's plus or minus 9i. It's plus or minus. It could be because the square root of 9 is plus 3. It could also be negative 3. So we got to remember that when we're taking the square root of a number like that, it could be plus or minus. So let's go back to our last page of notes. Don't want to forget that. Okay, let's solve each equation using the square root method, just like our assignment is for this time. So we've got to add 64. X squared equals 64. All right. Then we'll take that square root of both sides. So x squared, square root of that is x. And that's a perfect square, 64. That's 8, right? So it's plus or minus 8. Because negative 8 times negative 8 is also 64. So that's our answer. All right, let's do one that's not equal. Excuse me. That is not equal to 0. Let's do this one over here. So we got to subtract 5. So what we have is 81x squared equals 16. Okay, we're isolating the x squared. We're almost there. Got to divide by 81 now. So x squared equals 16 over 81. It's a fraction. Take the square root of both sides. All right. So the square root of x is just x. This can be rewritten, remember, as the square root of 16 over the square root of 81, which the square root of 16 is 4. We've got a plus or minus. 4 square root of 81 is 9. So x equals plus or minus 4/9. Plus or minus 4/9. Let's try one more. Let's do this one down at the bottom. That looks interesting. It's got a fraction in it to start. It's the coefficient. It's a negative. All right. So the first thing we'll do is we'll subtract the 1. So negative 1/2 x squared equals negative 40. Now, how do we isolate the x? We've got a negative 1/2. Well, if we multiply it by a negative, that'll make it positive. So we'll just have x squared. And if we got a half and we want to get rid of the fraction, multiply what's on bottom. Multiply it by 2. We just turn it upside down, 1/2. If we have 1/2, we can turn it upside down and multiply by that, and that'll get rid of the fraction. So multiplying 1/2 by 2 makes it 1. So but we're going to make it by negative. So we take the whole thing and multiply it by negative 2. So negative 2 times negative half is positive 1. So that becomes just x squared. Negative 2 times negative 40 becomes 80. Okay. 80 is not on our list. 81 is. We were close, but it's not. So we have to come up with a different number. So let's take the square root of both sides. Sorry for all the wiggling there. There we go. So we need some other numbers for 80. So if you want to think about it, 80 is equal to, I'll work over here on this other side, 2 times 40, 4 times 20, 5 times 16. Oh, that's a good one. So if we take the square root, x is equal to, so if we change this to square root of 5 times 16, 16 is a perfect square. We were looking for a perfect square. 40 is not a perfect square. 20 is not a perfect square. This is. So that means it is 4 times the square root of 5 plus or minus. Because this comes out. Square root of 16 comes out in front as a 4. Square root of 5 is the square root of 5. We can't simplify that anymore. So x is equal to plus or minus 4 square roots of 5. All right, so you have plenty of practice problems there. So if this is confusing to you, I would recommend you go look at these problems. It's in Google Classroom under Notes. Try working this on paper. If you get stuck, then come say, hey, Mr. Brock, I was trying to work this, and I don't know how to do it. Here's some more. Solve using the square roots method. So there's plenty of practice problems for you to make sure that you understand you know what you're doing. All right, let's see. Here's a question at the bottom. Let's do this together. Which of these equations can be solved by square roots? And how would you solve the other one? We've got x squared minus 9x equals 0. We've got x squared minus 9 equals 0. All right, well, when we looked over here, we said the ax plus c equals 0 can be solved with the square root property. This one has a b, 9x. If we move that to the other side, add 9x, we've got x squared equals 9x. Well, if we take the square root of that, we're going to end up with something really funny because we'll have 3 square roots of x, and this is equal to x. How do we combine those x's? You got to combine those x's. That's not going to work. This cannot be solved with the square root method. This you can just add 9. So you got x squared equals 9. So x equals plus or minus 3, right? That's a simple one. But how would we solve this one? Because there is a way to solve it. That's not by the square root method. We're going to erase that. Well, the first thing I see is there's an x in both terms. If we factor that out, let's not forget factoring. X times x minus 9 is the same thing as that. So that means x equals 0 or x minus 9 equals 0, which means x equals 9. This one is that's the two solutions for that. That's what we were doing a couple of lessons ago when we we're factoring. Two different answers. The two different answers on the square root ones are the same answer, but it's just the positive and the negative of that same number. Positive and negative. See, these are both 8, but one's positive, one's negative. These are both 4/9, but one's positive, one's negative. So with the square root method, this is 4 square roots of 5, which is a number. If we want to see what that number actually is, just so we have some concept of what number we're dealing with, let's do that. Let's put this calculator back up and say the square root, we're going to take the square root of 5 and then multiply it by 4. The square root, where's my square root button? Oh, there it is. Square root times 4. So this number is almost 9. It's about 8.94 is what x is equal to there. About 8.94. Well, you need to focus. That's terrible. All right. So yeah, all of these, even though they look funny with that radical there, you can punch into a calculator and find out exactly what the decimal is. Now, there's a lot of numbers there. You'd have to round it at some point, but this is just asking you to get it to this. We do not want the decimal. Do not put the decimal. Do not use decimals, which means you're not using the calculator to give me a final answer. Don't use decimals. This is the final answer. Leave the radical. If it has a radical. Sometimes the radical gets eliminated, right, with the plus or minus 8. So if it gets eliminated, it gets eliminated, which is fine. Leave the radical in your answer. Leave the radical in your answer. Because this is exact. This is an exact number. Plus or minus 4 times the square root of 5 is an exact number. This decimal that we had, that's not an exact number, because even at the end, this 1 is rounded, because it would continue if the calculator showed more numbers. This is not exact. This is a rounded number. So this is an exact number. We want the exact answer. So, all right. That is your look at how to use the square root method. Like I said, this week you only have 3 problems to do. So if you're behind on other ones, get caught up on those and get this turned in. We are running out of time. We've got like 3 weeks and change. We've got about 3 weeks left, and then we're going to hit the Christmas break, and your grades will become final at that point. So make sure your grade is where you want it to be when we get to that point. You got 3 weeks. So if you need help with anything, be sure to ask. So we will see you guys on Wednesday. This week, a B day for Friday. So I won't have this class on Friday, but we'll be here Wednesday. You guys have a great week. We'll see you next time.